So next question, discuss the nature and origin of Indian monsoon and recent techniques of its prediction. The regional and seasonal winds monsoon was identified by Arab scholars as seasonal reversal of wind patterns. The monsoon regions of the world are precisely confined to East tropical land with Indo-China Peninsula and India forming the prominent examples. These regional seasonal winds have been specified with wide range of determinants, which are analyzed by climatologists in different time frames to interpret the characteristics and origin of these regional seasonal winds. Two distinctive approaches are taken into consideration: classical concept, modern concept. Classical concept, thermal concept of Sir Hadley provides the differential heating of land and water forms the cause of seasonal reversal of in the wind pattern. During winters, prevailing high pressure over land causes northeast trade winds, which are offshore winds that generates dry conditions, whereas during summers, developed low pressure facilities onshore, southwest monsoon, generating weather condition. Okay, in reference to this approach, monsoonal winds form the example of enlarged sea bridge. Though largely Hadley's concept is followed in the monsoonal mechanism study, his treatment of southwest monsoons as sea bridge is significantly criticized by climatologists. The monsoonal effectivities exercised by remote continental interiors justify them to be much stronger winds than ordinary sea bridge. Concept of ITCZ Flown amended Hadley's approach. In his ITCZ concept, he specified that a southeast trade winds of southern hemisphere from southwest monsoon of India. Elaborating this, he specified exceptional bent of ITCZ in northern Indian Ocean basin, making southeastern trade approach northern hemisphere, causing somewhat precipitation in coastal Somalia and coastal Yemen in between 40 degree to 60 degree coast east longitude. Their trades under the effect of Coriolis force starts encroaching in India and into Indo-China and southwest monsoon. Significance of Flown's analysis lies not only in identifying the actual characteristics of southwest monsoon, but also in recognition of prevailing monsoon climate along western boundary of India. The monsoon concept, the classical approaches of monsoonal mechanisms facilitates the underlying understanding of ground condition. It, however, completely ignores the upper air connectivity that helps in analyzing variable set of monsoonal characteristics. The monsoonal expedition of 1970s attempted the analysis of this relation and concluded two important characteristics of southwest monsoon: north-south alignment, development of vortex. North-south alignment is modified Hadley cell, and the role of Tibetan plateau is specified. Tibetan plateau generates low pressure, reversing the condition in upper air. This causes the displacement of subtropical jet, which induces arid condition over India. At the high pressure developed over Tibetan low stronger arm Historically studied evolves, which facilitates the simultaneous intensification of Mesocrene high in Indonesia. This north-south alignment not just general tracer gradient but also maintains it for 3 to 4 continuous months, then justifying monsoonal season to be equal in extension with variable branches of southeast trade as southwest monsoons encroaching in India and causing variable and periodic rains. Vortex analysis. It is specified that with apparent shift of sun towards south-north equatorial meridian through shifts towards north encountering the land through this trough get divided into either shorelines of Indian landmass as the pressure profile of marginal water bodies is different than open Indian Ocean. The divided trough readily starts dissipating. The dissipation is strong in Bay of Bengal owing to its stronger continental location. The sudden beginnings of monsoon is explained by the fact that at the time of monsoon onset, pressure gradient force is significantly strong in India. The analysis of vortex also justifies the first monsoonal source in Kerala is due to Malabar vortex and direct encroachment of moisture-laden winds in Mahanadi basin due to Utkal vortex. Monsoonal prediction. Forecasting of monsoon is a challenging problem over the Indian subcontinent where monsoon constitute a major weather system affecting a large population. Short range, medium range, extended range and long range forecast are essential for various weather sensitive activities such as farming operations, flood forecasting, water resource management, sports, transports, etc. The fluctuation in monsoon rainfall in different time scale is influenced by occurrence and movement of different big question. So you can see in the diagram in January month and July month. So with this different weather system during season, depending on the time scale, the monsoon prediction can be classified into following 4 categories: short range up to 3 days, medium range up to 4 to 7 days in tropics. So extended range or intra-seasonal beyond 7 days up to a month, long range or seasonal 1 season. Current status of monsoon forecast. IMD has mandated to provide multi-scale weather forecast ranging from nowcasting to seasonal forecasting. While the existing system of weather and climate forecasting in India is geared up for providing forecast service in the short and medium range timescales, there exists a gap in respect of the extended range timescale. short and medium range forecast. With the commissioning of high performance computing system HPCS in 2009, NCP-based Global Forecast System GFS T382 has been made operational at the IMD Delhi, incorporating Global Statistical Interpolation GSI systems in the Global Data Assimilation System. The global model currently runs twice in a day and generates forecasts for 7 days. From 2012, IMD has started using high-resolution global model, about 25 km horizontal resolution. In addition to this, for the short-range weather forecasting, the mesoscale forecast system weather research forecast with 3D VAR data assimilation is being operated daily twice at 27 km, 9 km and 3 km horizontal resolution for the forecast after 3 days, using initial and boundary conditions from the IMD global model in addition at 10 other regional centers. Very high resolution mesoscale models WRF at 3 km resolution are made operational. The forecast products of these models are routinely made available on the IMD. The short and medium range forecast up to 7 days in tropics are very sensitive to the initial state of atmosphere from which the models begin the prediction. A better initial state will lead to an improved prediction. Higher resolution data are required to be assimilated for success in this range under the ongoing modernization program of the IMD. This issue has been addressed with the process of expansion and digitization of its observational network to achieve seamless data flow. From the ongoing modernization program of IMD, good quality dense observation, both conventional and unconventional, are expected to be available by means of Doppler weather radar satellites, inside 3D radiance wind profiles, GPS sound, meso network, automatic weather station, buoys and aircrafts in the real-time mode to ingest into the assimilation cycle of global and mesoscale NYMWP models, availing the advantage of advanced telecommunication system. Considering the need of farming sector, IMD has upgraded the agrometeorological advisory service from agroclimate zone to district level. As a major step, IMD started issuing district level weather forecast from 1st June 2008 for meteorological parameters such as rainfall, maximum and minimum temperature, relative humidity, surface wind and cloud octa up to 5 days in quantitative terms. These forecasts are generated through multi-mode ensemble system, making use of model outputs of state-of-the-art global models from the leading global NWP center. Extended range forecast on monsoon. So weather forecast is in extended range time scale beyond 7 days and up to a month. By using numerical models requires the role of oceans, and thereby a coupled mode is required for the same. For the forecasting of monsoon of this time scale, models must simulate and statistics amplitude, range, propagation and frequency spectra of the intra-seasonal oscillation correctly. It has come to light in the last couple of years that certain amounts of years interaction are involved with the summer ISO, and the coupled models are also in the development stage. Accurate prediction monsoon on this time scale, since the state of the art dynamical prediction systems for extended range MD8 range wave prediction of active break spells is not operational. In IMD, it generates the forecast of monsoon in this time scale based on the real-time coupled models outputs available from leading international centers such as the National Center for Environmental Prediction, USA, the European Center for Medium Range Weather Forecasting, and that of Japan Meteorological Agency. Forecast for 2 weeks for prepared using these coupled models output for the extended range forecast. In addition to the 2 weeks deterministic forecast, IMD has also started generating probability forecast on monthly scale from the beginning of 2010 by using outputs of coupled models from leading international centers. Presently, IMD is also working in collaboration with Indian Institute of Tropical Meteorology, Pune, for forecasting the monsoon in extended range timescale. Long-range forecasting of monsoon. IMD has been providing operational long-range forecast based on statistical techniques. The statistical approach has shown good skill in generating forecast for the seasonal rainfall over the country as a whole and for geographical regions: Northwest India, Central India, Northeast India, and South Peninsula, and that for the monthly rainfall over the country as a whole for the months of July, August, and September. IMD also generates operational forecast for the rainfall during the second half of the monsoon season over the country as a whole. However, the statistical approach has been found to have limited skill for monthly and seasonal forecast for smaller spatial scales such as state, subdivision, district, etc. In addition to statistical operational forecasting system, IMD has also established an experimental dynamical forecasting system for the long-range forecasting of Indian summer monsoon rainfall at IMD, Pune. The dynamical forecasting system is based on Experimental Climate Prediction Center (ECPC), Regional Forecasting Center model (SFM model), AGCM is being used to prepare monthly and seasonal forecast during the monsoon season using persistent and forecast SST as a boundary forcing. The experimental forecasting system has shown some useful forecast scale. The SFM model AGCM is being used to prepare monthly and seasonal forecast during the monsoon season using persistent and forecasted SST as boundary forcing. The experimental forecasting system has shown some useful forecasting scale. However, further improvement is necessary before the dynamical forecasting system can be used for a personal purpose. Monsoon Mission Minister of Earth Science, although the National Mission of Monsoon involved all relevant organizations and research institutes for the improving the dynamical prediction of monsoon. This has been approved recently by the Government of India and will be for a period of 5 years. The Pune-based Indian Institute of Tropical Meteorology (IITM) Pune will be the coordinating this program. IMD has the responsibility of operationalizing the monsoon forecast in all time scales achieved through this monsoon mission program. For the mission, the NCPCFS coupled model has been chosen as core model as the forecast of monsoon rainfall in the extended and seasonal range requires a good coupled model. IITM Pune is working on the Cape model NCES considered as core model under this mission. So thank you.